Okay, so a 27-year-old graduate beaten by coral snake. Basically, they're asking about rigor mortis, right? Cold and stiff means rigor mortis. After death, rigor mortis occurs. They are asking what is the mechanism of rigor mortis, basically. We all learned this thing in our school times. This cardiac, this not cardiac, but skeletal muscle and how it contracts and stuff. So basically, what happens is whenever there is action potential reaching here, okay. So this releases the calcium from this thing. This DHPR opens and there is calcium activated calcium release, that is rhinodate receptor channels and stuff like that, which is a type of L type only, but there is a bit more to that anatomy. You can read anatomy about it and physiology too. So whenever there is an action potential, basically there is release of calcium in the not cardiac muscle, in normal muscle, and then the skeletal muscle contracts due to this. Okay, that is a rough understanding about it. But how does it contract, right? So whenever there is, first of all, the calcium is released, it binds to troponin C. Troponin C. Okay. As soon as the calcium binds to troponin C, there is shift of tropomyosin to expose the myosin binding site. We all have learned this. I'm just repeating it. Okay, this is this tropomyosin, and it will move. So there will be a myosin binding site on the actin thread, right? So this here it opens, right? So that myosin head binds, and there is this ATP is associated with this myosin head, right? ATP. So this comes like this. Like this is ATP. It is attached like this, and this is myosin head. Okay, so myosin head binds to the myosin binding site. This doesn't require any energy. It is just there is a magnet, it binds. Now, when this ATP is hydrolyzed, there is a utilization of energy, and that will cause release of phosphorus and energy into this myosin head, and it will cause a push, right? This. Okay, this will strengthen the muscle. This will contract the muscle. Okay, as soon as this happens, the phosphorus is released and ATP is, resynthesized. It comes back to normal and it detaches, and everything comes back to normal. That's roughly the whole idea about it. You can read it in detail in your skeletal muscle. Okay, you can take a screenshot and read this one by one. You will understand it. It's very easy. It's just words. Okay, it's just words. But basically what happens is calcium is released, there is a contraction. How? By it binds to troponin C, tropomyosin rolls, the myosin binding site on actin is released. So the actin binding site on myosin touches the myosin binding site on actin. Got it? So this both attaches, the ATP is hydrolyzed, it causes the contraction, so the muscle is moved on this part, it stretches basically, right? And that is called the this cross bridge. This is called the cross bridge cycling. So what happens in rigor mortis? What happens in rigor mortis is, after a time, the glycogen stores in your muscle. Even if you die, your muscles are still living cells, right? Cell is an individual entity. Okay, till your cell dies, you can't die fully. Your just heart has stopped. That is the death. Your brain has stopped maybe, but still your muscles are active, and they are very, they are able to live in anaerobic conditions. They do not require much oxygen per se, but they can synthesize they can get their glucose from the liver and stuff like that, and glycogen stores are present in the muscle too. So this glucose will be used in synthesizing ATP by the cells. So there will come a time after a few hours that this ATP will be, depleted. This glycogen will be depleted. Glucose is depleted from the body. There comes this. This is the time when the muscle is in full contraction. When they were contracting, what did I say about contraction? The ATP or ADP plus PI molecule, it is back rehydrolyzed into ATP, right? When it is rehydrolyzed into ATP, the molecule comes back and it detaches from the actin, right? But now there is nothing to hydrolyze, nothing to create this ATP. So it always stays in this position. So the muscle stays in contracted position. That leads to rigor mortis. So what happened? This process was known as cross bridge cycling. So there was an inhibition of cross bridge cycling. Got it? Now activation of muscle contraction by neurotoxins, no, that would have happened later. That would happen immediately, but there is no muscle contraction by neurotoxins. Actually, the mechanism of this snake toxin, you have to learn a little bit forensics about this. I don't remember. There are two types. The two types of neurotoxic and hematotoxic. So neurotoxic leads to different things. Hematotoxic leads to different things. So you can learn it in your forensic medicine classes. Reduce affinity of myosin head for actin filament. No, they are just like magnetic poles. They don't lose their affinity. That is like the affinity is their intrinsic nature. They do not require any state for that. Effect of low temperature on muscle proteins. Yes, it might cause a contraction, but the question doesn't mention temperature, so you are not sure about whether he was actually in low temperature. It is cold because there is no circulation, but that doesn't mean it is low temperature. Everybody turns cold after that, even in countries like India and states like Rajasthan, right? So yeah, and depletion of intracellular calcium might be, but that's not the reason. Okay, the main reason is decrease in ATP. So the answer is ultimately inhibition of cross-break cycling.
Thanks for watching. Please give a thumbs up and subscribe for more.